All right, so welcome to the last video of this kind of essential skills series. Today we're going to talk about trigonometry, but before we do that, we're going to need to talk about the Pythagorean theorem. Oops, I can spell, I promise. So most of you probably remember the Pythagorean theorem as a squared plus b squared equals c squared. It's important to remember that the Pythagorean theorem only works for right triangles. So this has to be 90 degrees down here, one of the angles in the triangle, for that to work. And the two sides of the triangle are A and B. It does not matter which one is which. And the hypotenuse, the long side, opposite of the right angle, always has to be C. So a couple quick ways we can do this. Draw a triangle over here. These will not necessarily be to scale, but let's say we have one side of our triangle is 4 and the other side is 7, and we want to know what's on this last side. We can start with our a squared plus b squared equals c squared, where 4 and 7 are our two sides of this triangle. So I'm going to call the 4a and the 7b. I could switch which one's a and b and it would not matter. So that means 4 squared plus 7 squared equals c squared. So now we can just do our algebra. So before we take the square root, we're going to have to simplify this left side. It is very important that you don't do what I'm about to do. So I'm going to show you something wrong. Do not do this. You cannot cancel out powers that way. You can only do it if there isn't a plus or a minus somewhere in there. So with that all out of the way, here is what you do. So 4 squared is 16, 7 squared is 49, that all equals c squared. So if we add those together, 49 plus 16 is, let's see, 50 plus 15, so that's 65, equals c squared. Now we can take the square root of both sides, and the square root of c squared is just c. And the square root of 65 we can plug into our calculator, and with a little bit of rounding, we get 8.1. So that means this side of the triangle up here would be 8.1 long in whatever unit we're using. Maybe these are miles, maybe these are meters. But let's do one more example to show how this can be slightly different. Again, this triangle won't necessarily be to scale. Notice that the triangle is oriented slightly differently. Doesn't matter, still a right triangle. So let's have, this time we have the hypotenuse as 9. One of the sides is 5, and we're going to try to find this other side. We can still start with our Pythagorean theorem, where now we have to figure out what's what. This 5, let's just call that a because it's one of the sides. And let's just call this hypotenuse has to be c. The hypotenuse will always be c here. So we have a squared, 5 squared, plus b squared, we don't know b, that's what that question mark is, equals c squared. So now that we've learned our lesson about taking the square root of this, we need to rearrange things first. So let's start to simplify this. 25 plus b squared equals 81. We are still not ready to take the square root yet because we have a plus sign here still, so I'm going to move that 25 over to the other side. Subtract 25 from both sides. Let's see, 81 minus 25 is going to be, was that 56, I believe? Pull out the trusty calculator just to check. Yep, 56. So b squared equals 56. Now we can take our square root. And we end up with b equals, so square root of 56 is 7.5, to within rounding. So then that missing side that we had would be 7.5. A couple things to always check when you're doing this is the hypotenuse is always the longest side. this is the hypotenuse. So it's good to remember things like this because you can check yourself. So if, for example, over here, we accidentally put 9 in for b instead, we would get an answer bigger than 9, and that should throw up a red flag telling us, wait a minute, sides can't be longer than the hypotenuse. So we can check in this first triangle, the longest side is the hypotenuse, and in the second triangle, the longest side of the triangle is the hypotenuse. So we're good to go there. So with that taken care of, we're going to move on to actual SOH-CAH-TOA, or trigonometry. So I'm going to write SOH-CAH-TOA up here, and this is all just trig, which we will use all the time in this class, so get used to it now. So we're going to make another triangle here. Let's orient it slightly differently than before. So not the prettiest drawing in the world, but it'll work. So let's put our angle down here, make that 25 degrees. So there's that angle. And we're going to have the hypotenuse be 6, and we're going to ask for this side over here. So the first thing we need to do is figure out which of our trig functions we need. So it talks about sine, CAH talks about cosine, TOA talks about the tangent. So we need to think about which pieces of the rest of this we have. The O means opposite, the A means adjacent, and the H means hypotenuse. Well, we have 6 here, and 6 is the hypotenuse. So we're going to need one of the two with the hypotenuse. So now we need to figure out whether we have the adjacent or the opposite side. So if your math teacher told you something silly like x is always cosine, erase that from your memory right now, because it won't always be true. Here is our angle. It is down here in this corner of the triangle. Oops, that was terrible. I was hired to do physics, not art. So if that's our angle down there, the adjacent side is the side that touches the angle. So this side that I'm about to color in green is the adjacent side because it touches this angle right here. So this would be adjacent. This other one that I'll color in orange, yellow, whatever color it is over here, this side over here is on the exact opposite side of the triangle from the angle we have. So this up here would be the opposite side. But we have the hypotenuse, and we want to find the adjacent. So we need to pick which one of these has adjacent and hypotenuse in it. So that would be CAH. And what CAH means is that cosine of the angle, we'll call it theta, is the adjacent divided by the hypotenuse. So I recommend, until you get the hang of it and have done this a bunch of times, always write this out first. Then plug in what you know. So we know our angle is 25 degrees. We don't know our adjacent, that's what we're trying to find, so I'm just going to call it x, everybody's favorite variable, divided by the hypotenuse, which is 6. Now all we need to do is solve for x. So this one's pretty straightforward. X is going to be 6 times the cosine of 25 degrees. So I just multiplied both sides by 6. Note that I flipped the left and right sides of this equation. You are allowed to do that, so that's completely okay. Now we just plug this into our calculator, making sure that our calculator is in degrees. So 6 times the cosine of 25 degrees gives us 5.4 to the nearest tenth. So that would be our answer here is 5.4. So we can also double check. This is a side of the triangle that we just found, 5.4, and it is smaller than the hypotenuse. So we haven't broken any of the rules of right triangles, which is good. So now let's do another example. So let's do this triangle right here. And this time, I'm going to give you this angle down here, 34 degrees. And this side over here is 5, and I'm going to ask for the hypotenuse. So again, first we need to figure out what we have and what we are trying to find. So we are looking for the hypotenuse. That's usually the diagonal side. It's always the side opposite the right angle. So that's the hypotenuse that we're looking for, so we know we're either going to need sine or cosine, not tangent. And then the other side we have is this side over here. That's 5 that I'm coloring in blue. So 5's over here. 5 does not touch this angle 34 degrees. 5 is on the opposite side of the triangle as that 35 degrees. So this is the opposite side. So choosing which trig function we need, now we have opposite. Opposite shows up in tangent and sine, and we want the hypotenuse. So that means we're going to want sine. Again, get into the habit now. Start with the SO, the CAH, or the TOA. Because what that tells you is the equation you write down. Sine of theta is opposite divided by the hypotenuse. Then you can start to plug in what you have. We know our angle is 34 degrees, so sine of 34 degrees equals opposite 5 divided by the hypotenuse, which we don't know, so we're going to call it x. Now, a lot of people here just want to jump ahead in the math and do a bunch in their head and just say it's 5 times the sine of 34 degrees, but it doesn't turn out to be that easily here. So I'm really going to kind of show you guys this one. So I'm going to multiply both sides of the equation by x here. Then we have x times the sine of 34 degrees equals 5. And then we want to get that x by itself, so I'm going to divide both sides by the sine of 34 degrees. So we actually end up with x equals 5 divided by the sine of 34 degrees. So be very careful. This is why it's good to always write this out so that you don't accidentally do something wrong. It's worth noting that if you had accidentally done it wrong, then you would get a hypotenuse that was shorter than one of your sides, which should raise a red flag and tell you something went wrong. You probably need to double check your math. But having checked our math, knowing we're doing pretty well here, we're going to do 5 divided by the sine of 34. Again, making sure our calculator is in degrees. Oops, plugged it into my calculator wrong. See, I just checked myself. I got a number less than 5 and I was confused. It told me that I did something wrong. But here we go. This gives us 8.9, which fits our rules for right triangles because the hypotenuse is, again, the biggest side. Let's go ahead and throw a box around our final answer there. There's really only one more thing that you need to be able to do right now, just coming into the class. And that still has to do with SOH-CAH-TOA, but it is finding an unknown angle. So this time, I'm going to draw us, again, another triangle. Come on, I can make nice straight lines. If I believe in myself. Close enough. That's our right angle, just in case anybody's confused from my terrible drawing and not at all straight lines. And we are going to have this side here be 5, and this side here be 8. So we already have enough information to figure out the hypotenuse if we want by using the Pythagorean theorem. But let's say that we want to know this angle right here. We still have our SOH-CAH-TOA. It's still the same process. So if our angle is up there at the top of this triangle, then this side, the 5, touches the angle. So that makes this our adjacent side. However, this 8 over here is on the exact opposite side of the triangle as our angle. It does not touch the angle, so this is our opposite side. So we have opposite and adjacent, which tells us that we're going to want TOA, or tangent. So we'll start off, as I have before. TOA means that tangent of theta equals the opposite over the adjacent. And now we start to plug in what we have. So here we don't have theta. So we'll just leave it as an unknown. You could call it x if you're more comfortable with that. But we're going to use a lot of different variables in this class, so may as well get used to it now. Equals opposite 8 divided by adjacent 5. A quick plug into our calculator or just remembering fractions, and that's 1.6. So we have tangent of theta equals, and I'm going to leave a gap here for a reason you'll see in a minute, equals 1.6. So now we need to get that theta by itself. So when you have something like 2x equals 8, that x is multiplied by 2, so we need to unmultiply or divide both sides by 2 to get our answer of x equals 4. So what we need to do here is we have the tangent. So we need to untangent both sides of this. So what I am calling an untangent, let's get a hyphen in here, is known as an arctangent or an inverse tangent. So it would be tan to the -1, or some people call it arctan. Either way, it is the opposite of a tangent. So I'm going to do this in, we'll just do it in black. So I'm going to take the inverse tangent of both sides of this equation. And just like multiplying by 2 and then dividing by 2 cancel each other out, this inverse tangent and this tangent cancel each other out here. So we have now theta equals the inverse tangent of 1.6. So your calculator has an inverse tangent button. It's usually second tangent. So you'll see the little -1 power in there. And we can just plug this in, and rounding to the nearest degree, we get theta equals 58 degrees. So that means that this angle we had up here, sorry, gotta fix a couple formatting things, there we go. This angle up here is 58 degrees. And then don't forget geometry still happens, so the interior angles of a triangle have to add up to 180 degrees. So if we wanted to know this angle here, let's call it x, then whatever it is, x plus 58 degrees for this angle up here that we just found out, plus the other angle, 90 degrees, has to add up to 180. So if we subtract 90 from both sides, then subtract 58 from both sides, we should get x equals 32 degrees. So this little bit down here, gotta find a better way to do that, would be 32 degrees as well. So you could do this a couple other ways too. You could have done the Pythagorean theorem first to find this missing side up here, the hypotenuse, and then you could have used inverse sine or inverse cosine. But hopefully you're seeing that every single time I've done this, I've started with the same thing. I've written out SOH-CAH-TOA. I looked at my triangle to figure out which sides we have, which sides we're looking for. I picked which one of SOH, CAH, or TOA we needed, and then I wrote it out like this. Then I started plugging things in, and then I did my algebra very carefully. So make sure you practice it like this, showing your work, because especially in 105, a lot of times students get a little ahead of themselves and try to do too much in their head. Sometimes I even have to write stuff like this out, so it takes a lot of practice for it to become automatic. If you write it down, you can at least find your mistakes later. So hopefully these videos have been helpful for you. This is the last one for now, but there will be many more over the course of the term. I will be posting worked examples this way so that you guys can watch me talk my way through an entire example without having to take up more than half of a class to do it. So thanks for watching. Have a good day.